Welcome back to Algebra 1 Honors. This is Lesson 5-2, Dividing Monomials. Okay. We're going to start real simple and then work our way up to some that are a little bit harder. What we're going to do first is simplify a fraction. And you've done this, you started learning to do this in 4th grade, you really got into doing it well in 5th grade. Okay. And there are a number of different ways to do this. What you're looking for is the greatest common factor, which was covered in the previous lesson, to take out of both the numerator, the top, and the denominator, the bottom. Now, sometimes you'll look at it and right off the bat you'll see the largest number that you can take out of both the top and the bottom. Sometimes you won't. And if you don't happen to do that, then start small. I have to divide the top and the bottom by the same number, because then what I'm really doing, like here, I can see I can divide a 2 into both of those. Okay? So what I'm really doing when I divide the 2 into both of those numbers is this. Okay? The reason I can divide top and bottom by 2 is because what I'm really doing is factoring out a 1. Okay, now hopefully you learned in 4th and 5th grade that fractions are like chameleons. They have lots of names, lots of colors for the same value. If I had half of a box of Skittles, I'd have the same amount if I told you I had 2/4 of that box of Skittles or 3/6 of that box of Skittles. So those are all different names for the same value, the same amount. Okay? So what we're doing here when we simplify is we're kind of going the other direction. Okay? We're finding the smallest name, if you will, for this fraction. So the reason we can take out a 2 over a 2 is we're really factoring out a 1. Now then I can look and see I'm not done yet, though. I can do another 2. So if I take another 2 over 2 out of here, I'm left with 8 over 11. And 8 and 11 don't share any factors. In fact, 11 is prime. 11 only has 1 and 11 as its positive factors. So my answer here would be just 8 over 11. Now, if I was a real smart cookie, and sometimes I am and sometimes I'm not, I could have seen that the 4 went in here right off the bat. And I could have factored out a 4 over a 4 and gotten directly to that reduced fraction. But if you don't see it, then do it incrementally. Do it a step at a time. Now, down here, what do I do here? Well, you notice, first of all, I've got all multiplies here. There's no pluses or minuses hidden anywhere in the top or the bottom. So I'm going to look at the numbers. Okay? I'm really in my head going to break this up like this. 5 over 15, put my numbers together, and put my letters together. Okay? And now 5 over 15, I can divide a 5 into the top and a 5 into the bottom. And that's going to give me a 1 over 3. Always a good idea when you divide, put a 1, okay, so that you don't, because we don't lose, this is not 3 when I divide top and bottom by 5. It's 1/3. Okay, be careful when you get carried away in canceling that you don't lose the top and promote a denominator value to being a numerator value. All right, now I have to look here. W to the 4th over W squared. Really easy if you think about what exponents mean. That 4 means I've got 1, 2, 3, 4 W's all multiplied together. That right there, 2 W's multiplied together. W times W. Now, provided that W isn't 0, okay, it can't be 0 because it can't have a denominator that's 0. Provided W is not 0, I've got a 1 here, W over W. I've got another 1 here, W over W. Okay? I have nothing left in the denominator, that's okay. And I have on the top 2 W's multiplied together, W times W or W squared. Okay? Now let's do one more and then see if you see a pattern here that we might be able to use. Let's do number 2A here, one I inserted at the last minute. So here we're going to have 5 W's, 1. So I'm gonna break this up in my head like this. Put my W's together. Put my X's together. Okay? And then I'm gonna have 5 W's there. 1, 2, 3, 4, 5. 3 on the bottom. 1, 2, 3. Over here I'm gonna have 4 X's on the top and 7 on the bottom. Okay? And now I'm going to look for 1s. I'm going to reduce. Here's a 1. Here's a 1. There's a 1. And what I'm left with right here is W squared times, let's see, here's a 1, here's a 1, here's a 1, here's a 1. Now, I can't let the numerator just disappear. There's still a 1 up here because all these guys are in the denominator. So it has to be times 1 over 1, 2, 3. Okay? Now, let's see if we see a pattern. Over here, just looking at the W's, we had W to the 4th, W squared, and we ended up in our answer with W squared. Looks like maybe if we took 2 away from 4, we might get our 2. Let's see if that works over here. I have a 5 here and a 3 here, and if I subtract the bottom from the top, I get my 2. Now this one is just a little bit different, because if I take 4, top minus the bottom, 4 minus 7, I get a negative 3, okay, a negative 3. And so here we have a positive 3, okay? But as it turns out, this x to the 3rd, when it's in the denominator, okay, if I were to drag this x to the 3rd up so that I don't have a fraction, I would write this as x to the minus 3, right? So whenever a variable with an exponent is in the denominator, if it's positive, when you drag it up into the numerator, it becomes negative. If it's up in the numerator, like x to the 5th over y to the 4th, if I take this and drag it down underneath, then it's going to be x to the minus 5, and there'd just be a 1 left up here. Okay? So with exponents, dragging them across the fraction bar changes their sign. Okay? Now, so it looks like our pattern then, our shortcut might be to subtract the bottom exponent from the top exponent. Okay. Let's try the next problem and see if that works. So we have 32 over 8 times, I'm going to put my a's together, a squared over a cubed times b to the 4th over b squared times c to the 5th over c to the 4th. Right? So, largest number, I think I can see it here, it's going to be an 8. 8 goes into 8 once, 8 goes into 32 4 times. So I reduced that one. I have 2 A's on the top here, 3 A's on the bottom. The ones up here are going to cancel. I'm just left with a 1, and I'll have 1 A left on the bottom. So I can write it as 1 over A, or I could write it as a to the negative 1, because I could drag this guy up to the top and make him an a to the negative 1. Here, b, 4 minus 2, 4 on the top, 2 on the bottom. 2 are going to cancel. I'm left with 2 on the top and a 1 on the bottom. C to the 5th, 5 C's up here, 4 down here, 4 of them are going to cancel. I'm going to be left with 1c on the top. Okay, so my final answer, I can write 2 different ways. My final answer is going to be 4, let's see, 4 times 1 times b squared times c, and I can put the 1 or not. And then on the bottom, 1 times a, and these have all canceled. Okay, that's one way to write it. Or I could take this little guy, his exponent's really a 1. I can pull him up to the top, and I can write this another name as 4a to the minus 1. This guy gets dragged across the fraction bar, the equator there, and he turns into a minus 1. And then b squared c to the first. Okay. Now let's look at one that's a little bit harder over here. When I look at this one, what do you think I do with this one? This one kind of gets many people. Well, when they start using things that are very complicated looking, one of the techniques I always tell students to use is to substitute something simpler for the complicated expression. So your eyes should be telling you, just trust your eyes are amazing. There's an x plus y here. Oh look, there's an x plus y here. So what if I think of x plus y, I just choose a new name for it. You can pick a letter, you can pick a box, you can put a star there, choose anything you want, but I usually say let x plus y, and I think of it as a capital A. You can pick anything you want, a capital B, a box. So there's an x plus y, that's like having an A, and down here is another x plus y. Okay? So now my problem, I can write it, and maybe I can see it a little bit simpler. Okay? Now I have A times x minus y, and that's an x minus y, not an x plus y. Okay, so it's not represented by an A. And then on the bottom I have A squared. Now we can see I've got an A on the top and 2 A's on the bottom. Right, A times A. So one of them here will cancel, and one of them down here I'll be left with 1A on the bottom. And my answer would be x minus y over A. And then at the end, I plug back in what I represented as A. So it'd be x minus y on the top, x plus y on the bottom. Now, if you can see it the way it was originally written, and see that this and this are the same, then you can just do the subtract the exponent method. Right? This 1 minus 2 would give us a negative 1. Well, this is the same thing as if we drag this guy up and write him as a negative 1. Okay? All right, let's look at one pitfall, one hole that almost every student I've ever taught fell into. Okay, and that's why it's up here. Okay, and that's this. Okay, and what almost every student I've ever known want to do with this, guess what they want to do? It's almost human nature. They want to say, okay, x over x is 1, and x over x is 1, so 1 plus 1 is 2, and 1 minus 1, oh dear, that's 0. We're in a horrible mess there. But it turns out, even if this wasn't 0, that's not right. This is a no. No. Bad. You cannot do that. And let's see why. Let's see if we could do this with numbers. If you can't do it with numbers, you cannot do it with letters. So if we had 3 plus 7 over 9 plus 14. Okay? Now, order of operations. First, let's calculate what we know this to be. We have to do the top here first, and then we can divide by what we get on the bottom. So 3 plus 7 gives us 10. And then 9 plus 14 gives us 23. And we can't reduce that because 23 is prime. Doesn't have any factors except 1 and 23 positive factors. Now, if we applied our same theory, though, that we wanted to do over there, okay, if I did over here what I wanted to do over there, this I divide 3 by 3 and get 1, 9 by 3 and get 3, right? I would divide 7 by 7 and get 1, 14 by 7 and get 2. Then I'd have 1 plus 1 or 2 over 3 plus 2 or 5. 2 fifths. Is 2 fifths equal to 10 23rds? Well, remember a real quick way to check. You cross multiply. 5 times 10 is 50. 2 times 23 is 46. They don't equal, so they're not the same fraction. Okay? So, the moral of this story is that you can only cancel, okay, top and bottom, you can only cancel if you don't have pluses and minuses in between. Everything has to be a multiply. Now here you might say, oh, but there's a plus and a minus over here. Yes, there is, but this is a multiply here. In parentheses, times what's in parentheses. And down here I only have one factor, so actually two. This times itself. Okay? So the pluses and minuses are inside one of the factors. I'm canceling the factors, the multiplies there. I cannot cancel. Okay, so if I have something like this, just one more, 2x plus 9y over 4x plus 81y. I cannot do this. All right, I cannot cancel here, 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 and here. Wrong. Because there's a plus here and a plus here. It's not a time situation here. Okay? And that's what there is to dividing monomials.